Hi everyone, you're welcome to Explore Insight. In today's video, I want to teach you on how to convert hexadecimal number system to binary number system. If you are just joining this channel for the first time, please do well to subscribe. So without any further ado, let's quickly dive in. So like I mentioned, we want to convert from hexadecimal, which is 16, to 2. So all we have to do is to first of all think about the relationship between hexadecimal and binary. And we have that as 2 raised to the power 4. So that simply means if we have our hexadecimal, which runs from 0 to F, we should have the equivalents in binary. And how do we achieve that? I will take you through that part. So for we to have 2 raised to the power 4, it means the highest value that can appear here should be 2 raised to the power 3. Then we have 2 raised to the power 2, 2 raised to the power 1, and 2 raised to the power 0. Take note, this shows the place value. So we have 1, 2, 3, 4. Now 2 raised to the power 3 simply means 8. 2 raised to the power 2 simply means 4. 2 raised to the power 1 means 2, and 2 raised to the power 0 will give us 1. Now let's run through the conversion of hexadecimal to binary. For hexadecimal, which is 16, it means we have 0 to 15, and this 15 is represented as F. Please, if you want to understand more, do well to watch my first video. I talked about this. Now let's start with that. For 0, I'm going to use this key information for the conversion. So take note of that. Now for 0, 0 doesn't exist here, so we are going to put that as 0. Now let's see for 1. Yes, we have 1 here. It means every other value will be turned off. So we have 0, 0, 0, 1. And let's go for 2. For 2, we are going to have 0, 0, 1, 0, because we have 2 here. Now let's go for 3. We have 0, 0, 2 plus 1 will give us 3. So we have 1, 1 turned on. So let's go for 4. So we have 0, we have 4 here, so it will be turned on. And once 4 is turned on, no other value, so it's 0. If we check for 5, we're going to have a summation of 4 and 1. So that will be 0, 1, 0, 1. What about 6? For 6, the summation of 4 and 2. So we are going to turn this value on and others off. So we have 0, 1, 1, 0. Moving over to 7, we'll have a summation of 4, 2, 1. So these 3 values will be turned on, 1, 1, 1, whereas 8 will be off. Okay, so let's continue for 8. So in 8, we're going to have just this 8, and every other one will be turned on. So we have 1, 0, 0, 0. And for 9, it means 8 plus 1 will give us 9. So that will be 1, 0, 0, 1. What about A, which represents 10? We'll have a summation of 8 and 2, which is 10. So it means we'll have 1, 0, 1, 0. And for B, representing 11, we will have a summation of 8 plus 2 and 1. So that will be 1, 0, 1, 1. And C, representing 12, we are going to have 8 and 4. So if we sum that up, it's going to give us 12. So every other value will be turned off. So we have 1, 1, 0, 0. What about D, that is 13? So what will give us 13? 8 plus 4 plus 1 will give us 13. So we have 1, 1, 0, 1. What about E, which represents 14? We are going to have a sum of 8, 2, and 4. So we have 1, 1, 1, 0. And lastly, F, which represents 15. If we sum this up, it will give us a total of 15. So everything there will be turned on. Now, we'll be able to relate the value of hexadecimal to binary. So it means if we have 1 in binary is 0001. If we have 4 in hexadecimal, the binary will be 0100. Likewise, in F, it's going to be 111. So let's move to more examples and how we can take advantage of this calculation. However, in the next example, I will be using just this so that we can remember 8421. So let's just look at 4 examples right away. So remember, in this video, I always want to cover values with decimal points and without decimal points, so you'll be able to grab full knowledge on this conversion. So let me start with example 1. In example 1, we are asked to convert 64 in hexadecimal form to binary. We are asked to find x. So the first thing I will do is to spread out this value, 6 and 4. So like I told you, in hexadecimal, we are using that 8421. Please get this trick, 8421. I'm putting it on each of the value, okay? Now, for 6, how can we actualize 6 within this value, 8421? It means if we combine 4 and 2, it's going to give us 6. So it means my 8 will be turned off and my 1 will be turned off as 0. So 6 will be represented as 0, 1, 1, 0. Verify it. That is 4 plus 2 will be 6. Let's move over to the next value, which is 4. Now, we can certainly get 4, which is the same as 4. So it means every other value will be turned off. So we have 0, 1, 0, 0. I believe this is pretty easy. So it means even in an exam situation, if you take this in few seconds, you'll be able to solve that without going through the traditional method. Now with this, we'll sum that up. We'll have 0, 1, 1, 0, 0, 1, 0, 0. Remember, this is in base 2. So now if you are asked for x, our x is 0, 1, 1, 0, 0, 1, 0, 0. Okay, so let me move over to another example. So let's see example 2. Example 2 says the binary equivalent. So sometimes the question can come this way, but it shouldn't put you off balance. The binary equivalent of hexadecimal 5C2A in hexadecimal form will be what in binary? So this is the given question. All we have to do, the same thing. The solution would just be to spread this out as 5C2A. Now, what is the trick for hexadecimal? We know it's going to be 8421, having 15 as the highest value. 8421, 8421, 8421. Okay, so how do we use this to solve this given question? Now, how can we achieve 5 with this? It means 4 and 1 will be turned on because 4 plus 1 is 5. So it means 8 and 2 will be turned off. So we have 0, 1, 0, 1. If you confirm it, you get 5. Cross-check and you get 5. Now, C. What does C represent? C actually means what? 12. So bringing it back, what combination, what value can combine together to give us 12? It means 8 and 4. So in that sense, I'm going to turn on 8 and 4, while 2 and 1 will be 0. So let's go to the next value, which is 2. 2 can be found here exactly as 2, so we will turn others off, which is 0, 0, 1, 0. How about A? Now our A simply means 10. Now what can be summed up to get 10? It means 8 plus 2 will give us 10. But since we did not use 4 and 1, it will be turned off, while 8 and 2 will be turned on as 1. So we have 1, 0, 1, 0. Now, if we put all this together, it shows that our 52AH will be 0, 1, 0, 1, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0 in base 2. Take note, our x will be this given value. Interestingly, I would like to look at another example, but in this scenario, we want to work with decimal points. Now, consider example 3. Now, in example 3, we are asked to convert 69.25, which is in hexadecimal form, and we are asked to find the binary, to find x in its binary form. So the same way, all I have to do is to spread out this value, the given value, 69.25. Considering that it's hexadecimal, remember I'll just come here 8421, 8421, 8421, 8421. Okay, so this is my first trick in converting it. Now, what will sum up to give us 6? It is 4 and 2. So it means 8 and 1 will be 0. So we have 0, 1, 1, 0. What about 9? It shows that if I add 8 plus 1, it will give me 9. So I'm not using 4 and 2. So 4 and 2 will be 0. So we have 1, 0, 0, 1. I'll put in my dots and move over to the next value, 2. So 2, we can find 2 here exactly. And while this is turned on as 1, others will be 0. So we have 0, 0, 1, 0. What about 5? In 5, 4 plus 1 will give us 5. So 8 and 2 will be turned off as 0. So we have 0, 1, 0, 1. So at the end of the day, we are going to have 69.25H to be, putting this together, 0, 1, 1, 0, 1, 0, 0, 1, dot 0, 0, 1, 0, 0, 1, 0, 1 in base 2. Therefore, what is our value of x? Take note, 0, 1, 1, 0, 1, 0, 0, 1, dot 0, 0, 1, 0, 0, 1, 0, 1. We are just asked the value of x. So this will be the value of x. So let me consider another example, example 4. Now in example 4, we have the binary equivalent of hexadecimal number A, B, E, dot 3D in base 16 is what? So just to quickly solve this, we'll have the solution as spread out A, B, E, dot 3D. A represents 10, B represents 11, E is 14, we still have this 3, and the D is 13. When we go with the 8421, 8421, 8421, 8421, 8421. So we want to use this to assist for the conversion from hexadecimal to binary. Now for 10, what can sum up to give us 10? It's actually 8 plus 2. So 8 and 2 will be turned on, whereas 4 and 1 will be turned off. So at the end of the day, our 10 will be 1, 0, 1, 0. Moving over to 11, for the 11, 1 will sum up 8, 2, and 1. So 8 plus 2 plus 1 will give us 11. So therefore, 4 will be turned off. So we have 1, 0, 1, 1. Now let's move over to E. E is 14. The summation of 14 will be 8, 4, and 2. So 8, 4, 2 will be turned on, while 1 will be turned off. So we have 1, 1, 1, 0. Remember to put the dots. And for 3, we have 2 and 1. 8 and 4 will be 0, whereas 2 and 1 will be 1. And for 13, we'll have the summation of 8, 4, and 1. So 2 will be turned off. So we have 1, 1, 0, 1. So therefore, if we put everything together, it means that A, B, E dot 3D in base 16 is equivalent to 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 1, 0 dot 0, 0, 1, 1, 1, 1, 0, 1 in base 2. At the end of the day, our S will be this value. We've gotten to the end of this video. I hope you were able to grab a knowledge from this. If you are just joining us for the first time, please hit the subscribe button. And if you enjoyed this video, you can actually give me a thumbs up by hitting the like button so that YouTube can recommend my video. Do well to watch my subsequent videos on number system conversions. So I'll be signing off now. Have a nice time. Bye.